Welcome back to The Explainer. Today, we are stepping into the shoes of a robot engineer, and we're taking a laser-focused look at one of the most notoriously misunderstood areas in the entire Cambridge computer science syllabus: constructing logic circuits from logic expressions. If you've ever stared at a past paper question, maybe a tricky one from syllabus 9618, or even foundational concepts stretching back to 0417, 0478, 0983, 0984, and 2210, and felt your brain just completely freeze up, I need you to know that you are entirely not alone. Even top-tier candidates stumble here. It's high pressure. The clock is ticking. To really illustrate this, I want you to picture two types of students. Let's call them Alex and Sam. Alex is the overloader. Alex memorizes every single computer science fact imaginable, but when faced with a complex logic expression, he just dumps raw facts onto the page without any real analysis. He draws gates randomly, hoping something sticks. Then, on the other side, you have Sam. Sam rushes. Sam looks at the command word, maybe it says evaluate or analyze, but Sam treats it like state. He misses the entire command word requirement, skips the method, and tries to guess the final output. You can practically see the red pen marks all over their flawed answers, right? Well, our goal today is simple but powerful. We are going to program your brain for efficiency. We are going to build automated patterns for these common question types, demystify the topic, and reveal exactly what the examiners are looking for, straight from the principal examiner reports. So why do students find multi-step calculations and method marks so incredibly hard? I want you to really think about that for a second. When you are tasked with constructing complex logic circuits from expressions, it rarely comes down to just drawing a few gates and moving on. It is a balancing act. You're balancing Boolean logic, keeping track of binary data flowing through different nodes, and trying to land on one perfect final answer. The struggle is completely universal because the cognitive load is just so incredibly high. It feels like abstract math, and when that exam timer is ticking down, skipping steps feels like the most natural thing in the world to do. You think to yourself, I'll just jump to the final output. But as we're about to see from the examiner's perspective, skipping those intermediate steps is exactly where your marks are disappearing. Think back to our student Sam. Because Sam rushes and doesn't show the working, the intermediate binary states between the and or gates, when his final output is wrong by just one single bit, he loses everything. 0 marks. If he had just slowed down and documented his method, he could have saved that grade. We need to completely rewire how we approach these multi-step problems. Okay, here is the exact computer science success blueprint we're going to follow today. First, we'll examine the logic circuit challenge and what the assessment actually targets when looking at command words. Second, we'll uncover the incredibly powerful method mark strategy. Third, we'll walk through the core procedural framework. This is your automated pattern for success. Fourth, we'll look at the top 3 examiner warnings straight from Cambridge, so you don't make the same mistakes Alex and Sam make. And finally, we'll cover the critical analysis required to hit those absolute top grade boundaries. We are going to take those red pen marks and turn them into green check marks. Let's dive right into this. To truly master this topic, we first have to understand what the Cambridge benchmarks actually prioritize. It is so easy to get bogged down in memorizing massive amounts of facts, but as we saw with Alex, that is a dangerous trap. The examiners aren't looking for superficial breadth. They are explicitly demanding analytical depth. They want to see logical, structured reasoning over just a memorized list of logic gates. This is where you absolutely must master command word decoding. If the command word is describe, you need a different approach than if it is evaluate. And to guarantee top marks across these analytical answers, top students use the PEEL framework: point, evidence, explanation, and link. You make your technical point, provide evidence from the logic expression, explain how the data flows through the circuit, and link it back to the specific context of the question. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, keeping PEEL in mind, let's look at exactly how this framework maps to the examiner's grading criteria. It is incredibly useful to map out the precise cognitive domains the examiners are targeting. Look at this breakdown. You have knowledge and understanding as your absolute bedrock. Without mastering the precise definitions and fundamental principles, like what an XOR gate actually does versus an OR gate, the rest completely crumbles. Alex gets stuck right here in column 1. But that's just step 1. Then you move into application, where you actually apply algorithmic thinking and interpret data. This is where you trace a truth table through a complex circuit. Finally, you reach analysis. Examiners state that the theoretical architecture of Cambridge computer science rests heavily on understanding causal relationships. You need to know not just what a logic circuit does, but why a specific Boolean expression causes a specific output under a specific condition. This is where the Peel framework shines. When you explain the causal relationship, you are hitting that analysis tier perfectly, proving to the examiner that you don't just know the facts, you actually understand the entire system. So, how do we practically apply that deep understanding to grab every possible mark on a past paper? How do we rewrite those flawed, rushed answers and guarantee success? That brings us to Section 2, the method mark strategy. I cannot stress this enough. In complex, multi-step problem solving, the final answer isn't the whole story. In fact, the process you take to get there matters just as much, if not slightly more. We need to stop focusing purely on the destination and start rigorously documenting the journey. Let's look at exactly how this strategy works. The method mark strategy is absolutely brilliant. It is all about earning examination marks by demonstrating your procedural steps, regardless of whether a simple, silly arithmetic error messes up your final calculation. Think about data interpretation. When you are tasked with extracting information from binary representations, performing calculations, and drawing conclusions, it is a multi-stage journey. Let's say you have an expression with 5 different logic gates. You properly identify the first 4, you map out the intermediate truth table columns perfectly, but right at the end, under the pressure of the clock, you accidentally flip a 1 to a 0. Your final output is wrong. If you just wrote down the final answer, you did a 0. But if you do all the heavy lifting right and lay out your procedure clearly, examiners will still award you points for the correct intermediate steps. You have to prove to them on paper that your logic was sound. You have to literally program your brain to automatically document every single phase of your algorithmic thinking. Before we move to the interactive part of our strategy session, I want to share a fantastic memory hack directly recommended for this subject. Use a visual story method to encode logic circuit concepts. Instead of trying to blindly memorize a string of abstract Boolean variables like A and not B or C, turn them into a narrative. Assign a visual identity to an AND gate or an OR gate based on real-world conditions. For example, imagine an AND gate as a high-security vault that requires both a keycard and a retinal scan to open. Imagine an OR gate as a motion sensor that triggers if it sees a person or a car. Making it a visual story significantly lowers the cognitive load. It stops your brain from panicking when you see long algebraic expressions and helps you recall the exact data interpretation steps when you are sitting in that incredibly stressful exam hall. It's a total game changer for information retention. Let's transition now and see how this builds into an actual, reliable system you can use on exam day. We're moving into our interactive workshop phase. You can't just wing it when you get a complex logic expression. You need a systematic, algorithmic approach. This is our core procedural framework. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's look at the 5 steps that will fundamentally change how you answer these papers. Imagine a 60-second visual timer right here on the screen. We are going to do a quick data scan challenge. How do top students process complex data in under a minute? They use these 5 steps. Step 1, deconstruct the question. Before you draw a single line of logic, break the problem into its core components. What are the command words? Step 2, extract the core trend or data, often from binary representations. Step 3, select your analytical framework. Are you using a truth table, a Carnot map? Step 4, execute your solution, but you absolutely must do it with clear, systematic notation. Write down those intermediate values. And finally, Step 5, present your final answer using the correct, precise terminology. Use the Peel paragraph structure we talked about earlier. This deconstruct, solve, evaluate cycle is exactly how you logically sequence your answers. You don't rush the execution like Sam did. You plan the procedure like a robot engineer building a flawless system. But look, even with a solid framework, candidates still make critical errors. I want to shift the tone here to a critical alert. We're going to play a quick game of Find the Flaw. We've gone through years of principal examiner reports, and we have isolated the top 3 areas where students consistently bleed marks unnecessarily. Let's see if you can spot the sentences losing marks before I reveal them. Here are the 3 biggest traps. Number 1, vague answers. When you are describing a circuit or an algorithm's implementation, examiners are looking for incredibly specific technical details, not generalizations. If you just say the gate checks the input, you get nothing. Which gate? Which input? What is the expected output? Number 2, forgetting boundary conditions and edge cases. This is huge in logic circuits. When you construct a circuit from an expression, have you tested what happens at the absolute limits of the inputs? What happens if all inputs are 1? What if all inputs are 0? Does the system fail safe? Missing these edge cases is a massive red flag to an examiner. It shows incomplete analysis. And number 3, providing answers that completely ignore the context of the question. Let me show you exactly what I mean by this one, because it's the most common flaw of all. This right here brilliantly illustrates a classic mistake. The generic answer on the left is what Alex does. He memorizes a textbook definition of a logic gate, say a NAND gate, and he just writes it down verbatim. Examiners absolutely hate this. They give it 0 marks for analysis. Instead, look at the right side. Examiners demand an answer specifically linked to the given scenario. You must tie every single point you make to the specific real-world or theoretical context the examiner has provided in the prompt. For example, if the past paper question is about an automated factory sensor monitoring temperature and pressure, your logic circuit analysis better specifically mention those temperature and pressure sensors. Don't just call them input A and input B. Link it back. This is the L in our Peel framework, and it is non-negotiable if you want top marks. All right, if you fix those 3 mistakes, you are already doing exceptionally well. You've corrected the flaws. But how do we push into those highest grade boundaries? That takes us to our final section, critical analysis. Reaching the top tier requires deep evaluative thinking and mastering what we call the time management matrix. This means knowing exactly how much time to spend on the complex analysis questions versus the simple knowledge recall questions. You need to automate your timing so you have the breathing room to actually evaluate your logic circuits properly. So, what does evaluative thinking actually look like on a Cambridge past paper? It means you aren't just blindly solving the problem, you are critically evaluating the quality of the solution itself. This requires considering multiple solutions and analyzing the trade-offs between them. In the context of constructing logic circuits, this means evaluating circuit efficiency. Perhaps you identify redundant logic gates in the expression and simplify it using Boolean algebra. You consider if universal gates like NAND or NOR gates could optimize the physical manufacturing of the design. It means checking your final constructed circuit for reasonableness, acknowledging any limitations in your system design, and most importantly, justifying your design decisions with concrete technical evidence. It is the massive difference between simply stating this circuit works and arguing this circuit is optimal because it reduces gate delay and minimizes hardware costs. That is what an A-star candidate sounds like. I want to highlight this quote drawn directly from the syllabus guidelines because it is incredibly powerful and it sums up our entire strategy. Top-performing students exhibit connected conceptual understanding transferable to unfamiliar contexts. Read that again. It's not just about knowing logic circuits in a vacuum. The entire theoretical architecture of the Cambridge Computer Science syllabus relies on integration with other syllabus areas. Principal examiner reports explicitly state that candidates who reference cross-topic connections, like linking hardware logic to software algorithm efficiency, achieve significantly higher marks. Your knowledge has to be flexible enough to apply to a completely bizarre scenario you have never seen before in your life. You have to be the robot engineer adapting your automated patterns to new problems. We have covered a massive amount of high-value ground today. We completely decoded command words, implemented the PEL framework, leveraged the method mark strategy by showing every single intermediate step of our data interpretation, and we learned to avoid the trap of generic, contextless answers. The complete examiner's playbook is now fully visible to you. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @aceexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep structured, stay focused, and I'll see you next time.